So we looked at how carbon forms bonds. It is by sharing of electrons. Carbon likes to form these covalent bonds wherein it contributes one of the electrons and the other electron is contributed by the other element. In order to form a carbon-carbon bond or even carbon-forming bonds with other elements like hydrogen, nitrogen or oxygen. There are many more, but we talk about these four. If you really want to think why carbon is the universal element that is found everywhere in nature, the entire living kingdom is made from carbon. The molecules in your body, DNA molecules, proteins, lipid molecules, every single molecule in the body has carbon as the central element. Everything around us is pretty much made up of carbon. Wood is made up of cellulose, which has carbon. Medicines have carbon compounds. Paints and perfumes are made up of carbon. Why carbon? We should look at the way it forms bonds, so that in order to explain this ubiquity of carbon, carbon belongs to group 4A and elements in this group form 4 covalent bonds in order to gain the nearest noble gas configuration. Now think of carbon, it likes to form 4 bonds. Everything below carbon, silicon, germanium, tin, lead, all like to form 4 bonds. What is special about carbon that it is allowed to form so many compounds, about 10 million? Why do we have so many molecules made of carbon? One of the reasons is that carbon forms bonds with other elements, or even carbon-carbon bonds are just the right strength. In the sense, silicon also forms 4 bonds, but silicon-silicon bond is not strong enough to form chains of silicon molecules. When carbon forms bond with other carbon atom, the bond length and bond strength is just perfect, such that you can keep on making these carbon-carbon bonds and form very large chain of carbon. This is the first thing that you can form very strong and stable bonds. These bonds can be made in various combinations. You can have large open chains, closed chains. The open chains can further be stretched or branched chain. Closed chain is like a ring structure. Because these chains are strong and stable, we can build on them and make more and more carbon compounds. This property of making strong and stable bonds is called as catenation power. The other reason why carbon compounds are so widely found in nature is because carbon can make more than one type of bonds. It can make a single bond, double or even triple bond with other element or an other carbon. It adds to the complexity of structures that can be formed. Third property is that carbon compounds are not just made of carbon, but they have other elements, typically hydrogen, nitrogen and oxygen. Every time this element is introduced, it is going to add to the complexity of the structure or create variation in the structure. For example, we have 5 different compounds formed with one carbon atom, 2 hydrogen atoms and a chlorine atom, and have CH4, CH3Cl, CH2Cl2, CHCl3 and CCl4.
Let's look deeper in these reactions. Here we have methane, that is CH4. Now if we replace one hydrogen with chlorine, it forms CH3Cl, which is chloromethane. Now by replacing one more hydrogen with chlorine, we get CH2Cl2, that is dichloromethane. If we continue this process, we get CHCl3, which is trichloromethane, which is commonly known as chloroform. If we replace the last hydrogen atom with chlorine, we obtain CCl4, which is carbon tetrachloride.
Just with 3 elements, we can create 5 compounds. That is why we can make large number of compounds with the carbon. Another property of carbon compounds is that they can exist as isomers. What is isomerism? It is the ability of 2 molecules to exist such that they have the same molecular formula but different structural formula. To explain that, I am going to take a 3 carbon chain and I have the ability to place the chlorine on any one of these. Remember, when I place chlorine on the end carbon, it's going to give me a different structure than when I place the chlorine on the middle carbon. So you can imagine now that even though the molecular formula is the same, I have different structural formula. So it exists as isomers. That leads to further increase in the number of carbon compounds that are possible.